Okay, for people joining this live stream, this is another piece of designing microcontroller functionality for the next version of Wolfram Language. And you told me to look at the prototype build and do what with it?
Find the guide page, just type in microcontrollers, you find a guide page to it. And there should be an updated guide page.
This is not getting focus here for some strange reason. It's really weird. Oh, you know what happened? This didn't have, well, okay, hopefully this is the right version. Just a second, there's some bug here. You know what? That's really a bad bug. Is there anybody from project management here? Okay, I'm gonna have to type something for this bug. Okay. All right. Let's see.
No, it's not going to be there, Stephen. It's not the normal source. It's a Packlet source. It's instantiated.
So where, how am I supposed to get it?
The build documentation.
Oh, okay.
Microcontroller. The guide.
The third one.
Obviously, you should tell somebody that that searching sequence is wrong.
Okay.
Okay.
So right now, just in front of you there, you see there is two heading says deploying models, but that's just because an intermediary state we're in right now.
Okay.
Okay. The things that you pushed for is upload microcontroller code and generate microcontroller code.
Okay.
Okay. So those are new guide pages. Sorry, reference pages. And if you open the details, there's hardly any examples yet, but
so we went over this in great detail last time.
you wanted it this way in a list structure. That happened when I left the meeting, so I just found out yesterday from Suba.
Why did we want that?
I don't know. You wanted them. It's a mapping. It says, you know, it's
no. Yeah, you wanted it as that full form association. A0 goes to type analog.
But the other thing is also that the system and the mapping is in the list. It's a pair.
Why isn't this something like in the whole association, one of the elements is system arrow and then the thing?
No. System is way too important for that.
Okay.
This is
what? Why is it in a okay, as opposed to a third argument?
That's what we had initially as the third argument. You remember that the design you suggested, we had it as the second argument that was split into two.
What was split into two?
If you go to the top, look at the call box at the top. Okay, so what you had here, sys, microcontroller.
Mm-hmm.
That's what you added when I had left the meeting. Yes, last time. You insisted to have them in a list. Not sure why, but you did.
Okay.
Yes, because you suggested that we have the microcontroller code data feedback into as the first argument.
Sorry, the microcontroller what?
Code, that result. So from generate microcontroller code, if you get
that's why. Yeah. Roger, do you understand?
I do. But it doesn't have to be that way anyway. It's just it says that you can take code there as the first argument too. As another possible first argument that's distinguishable for sure.
No, it's certainly distinguishable, but I mean, then kind of okay. Okay, so what else do we have to talk about here? So this
That's
is what.
That's that. Then there's the entities. Super, where can we see them again?
Yeah, go to tutorial and the tutorials page on top. Yeah, just right on top right. Yeah, on the bottom, and the last one.
Supported microcontrollers.
Yeah.
Very nice.
Is that what you had in mind?
That's exactly what I had in mind. Exactly what I had in mind. So this has registered the entities in an entity store, correct?
Yes. So there are 3 entity types: microcontroller target, microcontroller vendor, and microcontroller family.
Beautiful. What are those weird things in there in the microcontroller family names?
Yeah, because that is the flash size, the flash memory size. So in that family, there'll be 32. It'll be Atmega 32.8, Atmega 16.8. That just stands for that.
What is the angle bracket? How is it usually written?
Oh, instead of that's a placeholder for 32, 16, 8, 4, and so on. It's Atmega 328, Atmega 16.8, 168, and so on. So we want to represent.
I understand that, but how do people usually do it? I mean, it's like x86 would be,
So shouldn't there be more of them? Do you want this? Shouldn't there be the 16 and 32?
Yeah, why aren't they
so
separated out in the microcontroller families?
Yes, so if you take that family and list the targets, one of that will be Atmega's 32.8 will be one of them.
So shouldn't that be it?
Okay, so listen. What you need is entity classes here. Okay, just like you have a specific country, Switzerland or something, and then you have the class of countries that are in, I don't know, the Schengen area or something. Do you get what I'm saying?
Okay. So instead of so that is a class of microcontrollers.
Right. So that can be handled as an entity class in the entity system.
Okay.
Right. That's
then the actual family, shouldn't that be Atmega 32.8?
I would think so. I mean, the actual, but then there's a class of. Okay, go ahead. What were you going to say?
So Atmega 32.8 comes in different packages, and that's part of that family.
Oh, so there are many Atmega 32.8s.
Yes.
Okay, so that's a family. So the actual family is 32.8, and there's a different family called 16.8.
Yes,
16.8.
Yes,
no.
And there's a class which is Atmega, star 8, Atmega star U4. Is that correct?
Yes. So the Atmega star 8 can have different packages. Atmega 32.8 can have different packages. Atmega 16.8 can be different packages. But why we put them as a family is they all have the same instruction set. So what you see as a family, all those microcontrollers have the same instruction set.
Okay, well, maybe the name microcontroller family is wrong. Maybe it's a super family or something. Do you get what I'm saying? I mean, so in other words, if in fact, whatever it is, Atmega.
But you can evaluate this and see what happens because this one doesn't require any hardware. You can, I think, just evaluate those inputs there.
I'm sorry. What am I supposed to be doing here?
Yeah, you can evaluate any one of those inputs, like this entity list microcontroller family. You can evaluate that, but you need to put needs microcontroller kit before that.
Yeah, if you want to, yeah.
Now you can take, say, for example, the first one and ask for targets. It'll tell all the different microcontrollers.
Okay, so I should be able to take this and then say targets.
Yes.
Yeah. Beautiful. Okay. So
that's
now,
a lot.
Okay. So what are these? These are microcontroller target entities.
Yeah, these are specific microcontrollers. So these are the specific microcontrollers. Microcontroller.
By the way, you need to fix the fact that that is a multi-word thing. You have to ask somebody how to do that.
Yeah. So this is my first iteration. I know the label. Yes, I'll get to that because right now I just duplicated it. I'll get to those.
Okay. And the way these underscores work is probably not what the common names want to be. They probably want to have spaces in there, unless the underscore is what the industry standard name of the object is.
No. Yeah, it's not. Yeah, it's a space. Yeah.
Okay. So that's the common name is what you're giving there. The entity name might have an underscore in it, right? The entity standard name might have an underscore in it.
Yeah. Yes.
Okay, but now this thing where you say microcontroller family, the main objection here is only this F thing. Is that industry standard to call it F, or did you?
No, it's not. It's something I came up with. It
okay,
stands for.
Yes.
It stands for 32.8. Do you see those there at Mega 32.8?
What is X then?
Yeah. So if you go to 80, yeah, just pick that and ask for targets. You'll see all the options.
But I don't understand. X is, what's the difference? Why are you calling it angle bracket F? What do you mean by angle bracket F?
It's a placeholder for different flash memory sizes.
Okay, but so you made that up?
Yes, I did.
Okay, well, I don't think it's the right thing. I mean, it's okay. So why don't you just call this at mega star 8? If you really want. I mean, and similarly at AT tiny star, or you could just call this at mega space 8 because that's the name of a family. But what's the industry standard name for a family?
Okay, I just picked it up from the database. If you look at mega 3 to 8, it just tells this is the instruction set for all these.
I understand that, but when people are referring generically to a star 8 object, okay, as you're doing here, these are all things with the number 8 in them. What do people in the industry call that collection? Here, you don't have to answer. Okay, so you're aggregating them to a higher level than people in the industry typically aggregate them. Is that correct?
No, all these have the same data sheet. So on the data sheet, they'll say that all at mega 3 to 8 / at mega 168 at mega 88, all these.
Okay, so on the data sheet, they list the specific things here. Is that correct?
Yes.
Okay,
yes.
So we need a notation. So I think at mega either star 8 makes sense to me.
Okay.
Roger, do you have a comment?
I think that's okay.
Okay, this looks nice.
I was more asking because you are the one with experience of naming conventions for entities and all of that.
Yeah, right. Well, I want to explain to you guys. There are two names for an entity. It's standard name, which is its canonical name that is typically camel-cased string, and for which that underscore is not magnificent. Okay, it's acceptable but not wonderful. Am I making sense?
Yes. Okay.
And the second thing is its common name, extracted with the function common name if you needed to, which is its print name. Okay, which can have spaces in it and all kinds of stuff. Am I making sense?
Where's the common name used?
In these yellow boxes.
Oh, so that's the common name.
So let me show you an example. If I say UK, for example, okay, that will say United Kingdom. Right?
And that can have a space in it. Common name can have a space in it.
Yes, that's correct. But here,
standard name cannot.
That is correct. And standard name, in a pinch, can have things like underscores in it, but is preferably does not have those things in it. Okay?
Okay.
Do you get what I'm saying?
Yes, yes.
Okay. Well, this is cool. All right, what else should we look at? This looks very nice.
I think that was it that we got to. Now we have additional things that we haven't yet looked at.
Okay, hold on. Let me just look at something here. Okay, that's all it says. All right.
Yeah,
Okay.
because we can add much more. We can add operating voltage, clock frequency, and so on. But I just duplicated what we had in microcontroller targets.
Okay.
We can make it much richer.
Okay, don't forget when you do clock frequency and things to put units in and so on.
Yeah, they already have units now.
Okay, wonderful. Okay, what else should we look at here?
Go back to the that one. Yes.
Yep.
So what we have looked at now is embed microcontroller code, microcontroller code data, and microcontroller targets, right? Those are the main new functions.
When did we look at microcontroller targets?
That's what became the entity types.
Oh, I see. Microcontroller targets is an option name.
This is a different way of giving that list of what possible targets are using the entity. And now we have to use the lookup framework for entities to find what are possible targets.
Fine. Okay, so then you're going to document that as an entity type. Right, so we should add that. You should talk to Alan about how to knit that into the collection of all the entity types. And notice that entity types, as of this version, are getting their own documentation pages. Okay.
And
so by the way, for example, that means you could link.
So
yeah, go ahead.
The name upload sounds so much like a web browser. It doesn't.
But you tell me what it should be. I'm not wedded to that.
I mean,
okay. You tell me what it should be.
Well, I think it doesn't need to be up or down load. It just needs to be load.
But it also generates the microcontroller code.
Okay. If we are having this discussion, because the last time towards the end when we were discussing this, you mentioned that embed code only does one thing. But the original reason why I called it microcontroller embed code was because embed code does both code generation and also moving it to a particular location.
No, it does not.
Based on the third argument. When it has the third argument, it does.
I see. Okay. All right. You are bringing up something which I am not. Location. Okay. All right. Fair enough.
For us, that connection port was that location. Now it's not in the built pages. And you can go to microcontroller. Yeah, you can go to.
All right. You're making a good argument for calling it microcontroller embed code.
Yeah, and I think it should just duplicate embed code.
Fine. What if it doesn't give the third argument? Is it going to just? It's binary CRUD, isn't it? That it sends out?
No. So if it doesn't give the third argument, in some microcontrollers, automatically it will go through and embed the code.
Sorry, I don't understand. The third argument here, which is actually the second argument in what we're doing here, right?
Yeah.
Well, okay. So you're making an argument here. You're making an argument. If it's with the analogy with embed code, you should get rid of that list which I incorrectly perhaps introduced, right? The second argument is the analog of saying Java or something as the thing, and then the third argument is where it goes. But what I'm saying is, if you remove the second argument, the third argument, if you remove the destination, what embed code does is to make a UI that gives you the thing to copy paste. Am I making sense?
No, it'll give you the microcontroller code data because it can give that one too, but it also has properties associated with that code.
Stephen is talking about embed code.
Yes, that's what I'm referring to. So if the third argument is not, embed code gives the source code, right?
Yes.
In both cases. In our case, we return this data object.
Right. So you give the source code too, Stephen. It's just a URL to point to it.
I'm totally confused. You're saying if you remove that third argument.
No, I'm saying what we should do for microcontroller, it should return microcontroller data, right?
Microcontroller code data.
Correct. I think that's consistent. What you said, if you give the 2 argument for embed code, it gives you a link. But that link gives you the source code. That is the source code.
So you're basically removing, you're right. This should be the 2 argument embed code form should give you back microcontroller code data. The 3 argument one should deploy it to a
exactly
UI or something.
So
okay.
if you click that embed and yeah, if you click that and change that to new microcontroller embed code new. I also worked out this design. You'll see in the details how this will.
Okay,
it's
so
all the same.
Yeah. What are you showing here?
Yes, it's the okay. Probably didn't. Yeah. So if you want a specific
that specific thing here, you don't need that. You don't need the third argument. What is in the third argument? Yeah,
in the connection port. But some microcontrollers, the programmer will automatically detect the connection port and embed the code. So for those microcontrollers, I included this connection port going to none. If you just want to generate the code.
But one thing that would be good is when you don't have hardware hooked up, that it just returns to the code.
Yes, exactly. So what I'm saying is, in the case where you just say microcontroller embed code with 2 arguments, okay? 2 arguments. Then you're saying return microcontroller code data. That's right. That's what you should do. Do you get what I'm saying?
Yes.
Okay. And then that microcontroller code data can be interrogated to get byte arrays and so on out of it if necessary.
Mm-hmm.
Right?
Yeah.
If you give a third argument and the third argument is a naked string that just says dev tty whatever, that will be assumed to be the connection port. Is that correct?
Yes.
Right. Okay. Now there is another thing here. Let's just discuss, this is a fine point, but even when you give the third argument, it returns microcontroller code data, but it also maintains the fact that it's connected, that it's loaded. So I'm saying you can see an indication that it succeeded.
In the code data.
Yes.
Yes.
So you want to return from microcontroller embed code, you want to return the code data object, come what may.
Come what may, but with different indicators. If you don't have a port,
I got it. It's got greens and reds and all that kind of thing.
Exactly.
Okay. Sounds sensible to me.
Okay, so this is we'll do microcontroller. Yeah. So there was another fine point Roger said. So because originally we had embed microcontroller code, and then you tweaked it.
Microcontroller embed code is better.
Okay.
Okay. Let me just show you one thing here.
Yeah, and the other reason.
Yeah, let me show you one thing. Okay, so this is the new mechanism, function compile export library, and so on. This is the new mechanism for the compiler.
Oh, so we have separate export functions?
For what?
For all of these are like versions of export, looks to me.
Unfortunately, they are somewhat subtle, to put it mildly.
No, I believe you. I certainly believe that.
And some of these things are bizarre versions of it. I mean, yes, ultimately this does compilation, right?
Yeah.
I mean, it's possible that one day we could just get away with using export with various.
No, I believe you, Stephen. I can see how many things that you might want to control to get it flexible enough. So
okay, so one of the things that this does.
But look at this, So then you need a string and byte array versions of it too.
Yes, but they do different things. See, there's binary versions. There's basically assembly code and there's object code.
I see. Okay, so byte array is object code, I assume.
Yes. Export allows both of them. I mean, it's possible when we have this all working that we will just be able to take a compiled code function yeah, and use that. What I was looking for was the mechanism for Let's see. Wait a minute. Oh, this is an old version. This is before today. Sorry. I have to update this. I wanted to show you the mechanism that it has for target architectures.
Right. And there was one other thing there. If you go back to my...
Yep.
So there's one thing that's relatively small, but you might have opinions about, which is systems connections model. That relates to sort of our whole control framework, control design systems framework. It's just a better way to knit together and wire together system models. More flexible than what we had. Because the original control framework had things like feedback connect and parallel connect.
Yeah, but what is this?
This is a general graph.
Yeah, it has a guide page in the regular ref pages.
Ref page. It is a regular source guide. It's a ref page.
Connections model.
Yes.
It's a model of system connections.
Systems.
MS.
I see. So this is the analog of serial, parallel, this, that, and the other.
This generalizes all of those because it gives you sort of general connection topology.
Right. Let me just show you one thing here. So this has a target system option that is set to a system ID here.
Right.
I'm not necessarily advocating this. I'm just saying this is a different mechanism. So what you're doing is you're providing the target as a second argument, which is, I think, the right thing to do for an embed code. I'm just thinking through what that looks like. Yeah, it's fine.
Yeah, because the first argument is what, the second argument is where, and the third argument
is how, so to speak. Yeah.
Yeah.
Okay. All right. What's your point here? How does this work?
So the reason we want, because when we generate code for these systems, we don't want to just munch them into just one function. So when we have this multiple subsystems, the equivalent code is also going to be different subroutines in the C or C code, the source code.
Yes, but how do you do? What are the entry points to the different subroutines?
So that's okay. If you look at an example, go a little down. But there's even, I think I even have an example of C. So, or you can go all the way down to applications. I think where I have a application example for this microcontroller kit.
What is this?
Oh, forget the
systems. Okay, so this is. Oh, I see. This says, but these things don't have named ports because they're just matrices, so they have just numbered ports.
Right.
System and port, that's how it's referred to.
System 1, position 1.
Can I ask you how that corresponds to the way ports work in neural nets? I think it might be worth looking at how those work, because I think what you have might be somewhat similar to what exists there.
Yes, it is. Okay.
Okay. Applications?
Yes. So we want to embed that systems connection into a microcontroller.
Wow, that's pretty sophisticated. Okay, all right. So it's a state space model which has some kind of two-step lagging stuff.
It just takes the inputs and it's moving average.
So that defines the 3 subsystems.
Yes.
Okay, then you wire them together.
Okay, great.
And that stays. It needs to stay as a wrapper like that because it cannot always reduce to, it's unreducible. Do you know what I'm saying?
I get it. I mean, that's great. And I mean, is that picture a realistic picture, or is that picture?
I think it's canned.
Okay. Okay, so
we cannot
this,
show too much detail.
yeah, I understand, but this reminds me a lot of NetGraph.
Well, it solves a sort of very similar problem.
Yeah.
Yeah, and encouragingly, it works the same way. So the only difference is the port mechanism. Okay.
Yeah.
Do you get what I'm saying? And also another thing that you might want to get.
But so we haven't gone back to work on control for many years, as you know. That we disbanded.
Yeah, right.
Okay. So there are many things that we could and should do eventually.
Okay. So, I mean, you want my input on this function. My only comment is the second case of NetGraph, where you're using named things rather than numbered things, you might also want to support.
But we don't have names.
Yeah, we don't have names because we could potentially, that's a control thing. We have system model labels, which can use strings and images. So we don't really refer to them. If it's a string, we can use.
We don't want to do that now, Suba, because it has many consequences.
Yeah, right. But I'm just saying for the future, you might want this case as well.
Yes, we do. But that's what I was kind of beginning at. So there are many things that need sort of a TLC in control.
Right. Now, in terms of the way, okay, so the net port. I see. You should just read this through about how ports work here. Because I'm wondering whether the nth layer has.
But see, they worry about things like computing gradients because you can't do the fitting without the gradient. Do you know what I'm saying?
I understand. I understand. I'm just wondering whether there's a notation here that's different from your notation that represents the port of a subsystem, effectively, or a layer in that case. I don't think so. I don't think it's incompatible. By the way, you might, just for the heck of it, you might want to refer back and forth between NetGraph and this thing.
Okay.
As a last kind of throwaway, reference.
See also.
Yeah. This looks perfectly reasonable to me. It's pretty nifty.
Okay. One more thing.
Yes.
Final thing.
Yep.
Okay. Get back to my.
Yep.
External type signature. So I think that we haven't. There's a bunch of projects that's moved on since this was originally crafted. And I think we have standard types. For instance, numeric array has standard types.
Where did external type signature? I mean, that's part of the. It's part of a bunch of these things. It's part of the external function mechanism and so on, isn't it?
Yes, it's part of the input ports and the output ports, even the system model. It's part of everything, basically.
What are you talking about? External type? What kind of thing can external type signature be? Like integer 16 or something, or what?
Go to the page. Go to the page.
No, we didn't document it because this is documented for embed code. But yeah, it's similar.
Oh, embed. Oh,
okay. Why is this so slow? What is it doing? Oh, great. Case rules mapping to external types in embedded code. What? In an embedded code? That doesn't make any sense. Oh boy, this is something we have to look at in connection with a compiler. What's your point about it right now?
Yeah, so for us, if you say external type, so the details, the penultimate one, external type goes to that particular type. It tells the return type of that function. For example, in serial, we want to say that the data coming in is of type int or real and so on. And so we'll use that data type in the source code for that.
In what source code?
In the generated source code.
Oh, okay, fine. But this is an option to microcontroller embed code. Is that correct?
Yes.
Okay. But I think that we shouldn't use the lowercase int and things like that, should we?
No, we should use integer 16 and all those kinds of things.
Okay, yeah. Because
wait a second. Wait. External type signature. The thing that it says here. Oh boy.
I looked at this and I thought this was because the other one we have to make a mental jump from those canonical names to this. So we just say what is this directly.
Sorry. This here is the raw external type specification, right?
Yes.
And what are you suggesting? That we use a curated type like integer, like one of our actual type objects?
No, I'm just saying we used it just like how it's here. That's how even in microcontroller embed code it's used. We can say external type signature goes to int.
Oh, you want to use this?
Why do you want to do that? Int is what in what language is int?
In the source, right now we're only generating source code in C.
Okay, but I'm saying that what you should do, maybe you can support int as an alternative, but I think you also should support, things like integer 16 and so on.
Yeah,
right?
I don't yet, but we can do that. Yes.
I'm all in favor of us doing both, because then there's a group of users that want the raw thing.
Right.
And
so we should use the types that are already specified for binary read list and which are being specified in the compiler.
I think the most systematic such list today exists for numeric array.
Fine. Just for 1 second, and then I really need to go. The relationship between this and the compiler. So the compiler is generating potentially C object code, right? Or it's generating, it could be generating actual C code.
Right, but it doesn't support full C code. These microcontrollers are not,
Okay, so the one question is there an LLVM to microcontroller transformation?
It's very sparse. Yeah.
Okay, fine.
Yeah, there's not much. I have not seen much effort in that direction.
Okay.
I can't imagine our compiler projects can tackle microcontrollers anytime soon.
Okay, fine, no problem. Just asking. Okay, it's happily tackling CPUs.
Yes.
And maybe the net, the neural net stuff will tackle TPUs and so on.
And GPUs.
Yes, I think the LLVM stuff can tackle some GPU stuff. All right, I think we're done here. Anything more?
I think this is it. We want to put it together now as tight as we can, and maybe we do a kind of a wrap up, because we should talk about some of the follow-on projects and all that too.
Yep. Okay, and how to tell people about it. All good.
Exactly.
It's very nice. Very nice. I didn't know what was happening on this, and this is all great. All right, thank you all, and see you soon, and have a good trip, Suba.